this classroom daily 5 o'clock according to your requirement. Sunday, there is day after tomorrow we are going to have accountancy for grade 12. Monday again we will have 10th standard physics. Tuesday we will have biology for 11th. Wednesday, that is 22nd Wednesday, we will have physics again for grade 11. Thursday, that is 23rd, we will have accountancy. Then again next Saturday we will have life skills. So let us plan up to this. Then next session I will tell you more about what is going to be there in the preceding week. So this is the picture. So according to your requirement, you plan and watch this show and make use of the classes. Right? This is considered to be the biggest classroom. Okay, so you can very well converse with us at any point of time. Right? So before the break, I had given you a question for calculating or finding out what's the value of dielectric constant of free space. Can you say what it is actually? How much is the value of dielectric constant of free space? So what is dielectric constant first of all? Dielectric constant is nothing but relative permittivity. Relative permittivity. How to find relative permittivity? Permittivity of the medium divided by that of free space. That means we know epsilon r is equal to epsilon by epsilon naught. This epsilon r is what is nothing but the dielectric constant. So if it is free space, the medium itself is free space. That means instead of epsilon, it is epsilon 0 only. So what's the dielectric constant of free space? The answer is 1. I gave you the answer to the question which I asked before the break. That is, the value of dielectric constant of free space is 1. Okay, maybe asked us a 1 mark question. So then we will continue with the questions which we have been discussing before the break. We have done up to the question number 13 in the sample papers. So now you can have a look at the question number 14. Can you make out what's the answer to the question? The athlete pedals a stationary tricycle whose pedals are attached to a coil having 100 turns each of area 0.1 meter squared. The coil lying on the xy plane is rotated in this plane at the rate of 50 rpm. That means revolutions per minute about the y-axis in a region where the uniform magnetic field is 0.01 k cap. That means it's along the z-axis present. Find the maximum EMF and average EMF generated in the coil over one complete revolution. Maximum and average EMF. So there are some questions related to calculation of induced EMF in this way, giving the values of the area, number of turns and things like that, rotating and all, But very first thing is about the RPM, revolutions per minute. What is given over there is the angular frequency, revolutions per minute. We should convert it into radians per second. So how do you convert revolutions per minute to radians per second? So 50 RPM, 50 divided by 60, that much revolutions per second. Revolutions per second. But to make it into radians, just multiply it with 2 pi, because one revolution is 2 pi radians. Is that clear? So we get 5 pi by 3 radians per second. This is omega. Anyway, let me tell you something in general about these kind of questions. There are two ways this question is usually asked. The first thing is like, suppose this is the coil. This coil may be rotated like this way of rotation. If it is rotated in this way, it is what is the situation in the case of similar to what's happening in AC generator. Whereas another case you might have done that question, if you remember the equation half B R squared omega, that's the equation we have for the rotation of the wheel or a ring in a magnetic field like this. So that is, this is the magnetic field. So this way it is rotated. That is there, which equation we will use? Half B R squared omega. If you rotate it like this, which equation? Concept of AC generator. There, which equation? The equation for the EMF developed in an AC generator, we have seen E is equal to E0 or E naught sin omega t. Remember the equation, E equals E naught sin omega t, sinusoidal variation of the EMF. But how do you exactly make out which equation to be applied? An easy way is there. If the question is related to half BR squared omega, the question will be just to calculate EMF, right? EMF, calculate the EMF induced or induced current, something like that. But if the question is where you are going to use E0 sin omega t concept, that is like similar to that of AC generator, there the question would be to calculate maximum induced EMF, average induced EMF. Questions will be like that. Why? Because that sinusoidal variation of the EMF, the value keeps on changing with respect to time varying quantity it is. But the other one is not like that. Half BR squared omega is not varying with time, it is a constant EMF developed. So from that term, or how it is asked, is it to calculate maximum, or is it to calculate average, or simply calculating induced EMF? So from these three terms like maximum, average, induced EMF, or simply induced EMF. So accordingly we can make out which equation to be used. So here the question is calculate maximum EMF. So it is similar to what's happening in AC generator. So maximum induced EMF is, what's the equation for maximum induced EMF? We have the equation NBA omega. NBA omega, that is number of turns we have, it is given number of turns in the question given is 100 turns. Area is given 0.1 meter square. There is no conversion required also because meter square it is given. Magnetic field 0.01 Tesla. Right, all the values are given in SI unit. Omega we have here. So just calculate this one, substitute the values and calculate. That will be the maximum induced EMF, that many volts. This is the first part, maximum induced EMF. How about second part, average induced EMF? Average induced EMF is, what's the average induced? It is AC now, right? So AC means average is how much for, and also it is given for one complete revolution. For one complete revolution, the average is 0. We proved it in the chapter AC alternating current circuits, right? Average for one complete cycle is 0. You remember the another equation? I think you must be knowing this equation, 2E0 by pi. When do we use this equation? For finding the average for half a cycle. For half a cycle, 2E0 by pi, and for full cycle, for complete revolution, what's the average EMF induced? It is 0. We proved it. So the second answer is 0 is the average induced EMF. I hope it is clear. So this is maximum, this is average. Correct? But the other one, if it is asked about vertical diameter, if it is rotated and all, if the magnetic field should be like this. So you think of the, refer the diagram which you have seen in the chapter electromagnetic induction and find out how the equation comes out to be in the expression for induced EMF. Half B L squared omega for a conducting rod rotated with an angular speed omega, and half B R squared omega for the ring or a wheel or a disc. So I think you remember one worked out example. It's a very significant question given in the chapter electromagnetic induction. Worked out example to calculate the what you call as the induced EMF developed in a wheel having 10 metallic spokes. Remember the question, 10 metallic spokes. You can see it is in the bracket, it is given. The number of spokes is insignificant. So do not take the number of spokes, that 10, it will be given 10 metallic spokes, but or number of spokes will be given, but that is insignificant. Why? Because as far as wheels are concerned, one end is to the center, the other end is to the rim. So these can be considered as connected in parallel. Parallel means what? Whatever is the PD developed across one road, same will be there everywhere. So you don't need to consider the number of spokes. Is it clear? So half BL squared omega over there, or half BR squared omega. But in this question, maximum induced EMF for during rotation, like in AC generator, that is E0, which is NBA omega, and average for complete cycle, it is 0. How about if the average was to be, we were to calculate the average for half a cycle, we were to use 2E0 by pi. Is it clear? Okay, now we move on to the 15th question. You look at the question 15 and 16th question you can see on the screen. Read the question carefully. This is again a relevant question for the exams. That is, we were to find out the number of photons emitted by this source in 2 minutes. 2 minutes time, how many photons are emitted? The power is given as 66 watts. Right. So now come back to this. Okay. look at the board. Power is equal to energy divided by time. Talking about the 15th question. Energy by time. Energy is due to the falling of the photons. If there are n photons falling, total energy will be what? N h nu. H nu is the energy of one photon. Photon picture divided by time. But again, you can rewrite what you say nu as what? Nu is c by lambda. Why we are changing like that is because we are going to see the question and see in terms of what it is given. Wavelength is given, not in terms of frequency. If it was given frequency, then you would not write this. All right. So what we are going to find is how many photons are emitted by the source in 2 minutes time. So n is the question. So n is equal to what then? Power times t times lambda divided by hc. Is clear? I think all of you can see it. Power is 66. Time 2 minutes. 2 minutes means 2 into 60, that is 120 seconds. Wavelength 600 nanometer. Remember, nanometer is to be converted into meter. Nano means 10 raised to minus 9. Right? So 600 nanometer, 600 into 10 to the power minus 9. C, speed of light, 3 times 10 to the power 8. And h, 6.6 times 10 to the power minus 34. Time is 120 seconds. Power is 66 watt. Why the specific value 66 given? Because 66 over here and this is 6.6. You can cancel them. So for very simple calculations, the value data is given like that. It is a simple calculation. Okay. The number of photons you can calculate like that. The number of photons, no unit, number. Right. This many photons are emitted in 2 minutes. I hope it is clear. Now we look at the next question. The 16th question you see. Look at the next question. So in the 16th question, it's actually the content is related to what's coming in electronic devices. Okay, electronic devices. The current flowing through 1 ohm resistor we have to find. Okay, all of you see the question. See, I think you can make out from the diagram. Just you have to look at the diagram carefully and I'll tell you. The first diode D1, you see, the diode D1 P is connected to positive. So D1 is forward biased, whereas D2 is reverse biased. The reverse bias means as far as the ideal diodes are concerned, reverse biased diodes do not conduct. So the central branch, the branch containing 2 ohm resistors, there is no current. So just delete that, take out that. Then what will be left? 2 ohm and 1 ohm. 2 ohm plus 1 ohm, that is 3 ohms. So total resistance is 3 ohms. Total voltage is 6 volt. So 6 divided by 3, that's it. 2 ampere is the current. Finished. Through 1 ohm resistor, current is 2 amperes. Clear? 2 ampere current. Now see the next question. The table shows identify the type of materials X and Y. X and Y. So susceptibility minus 1 to 0. Susceptibility minus 1 to 0 means what? It is within small negative susceptibility. Small negative susceptibility is which one? It is diamagnetic material. Alright, and the second one, Y, large, big susceptibility, large positive value susceptibility is for ferromagnetic substance. Then how does susceptibility and permeability of X and Y vary with rise in temperature? Rise in temperature, diamagnetism is independent of temperature, whereas ferromagnetic it decreases with increase in temperature, correct? And the next question, you see, 2 wires are aligned parallel to each other, one is carrying an electric current and the other is not. Will there be any kind of electromagnetic force between the two? Give reason for your answer. Answer is there is no force, because only a magnetic field can exert force on another magnetic field. So there should be 2 fields. Here only one magnetic field is there, the other one is not carrying any current. There is no, it is not moving as well. So there is no force at all. No force at all. So we have discussed today 18 questions from sample paper's latest paper. So the remaining questions we will take up in the next session. But again, the next day for the class 12, I will give you general guidelines for writing the examinations, board examinations. So make use of that. And now anyway, it's the time for us to wind up the show. I think all of you make use of this. and tomorrow you are going to have soft skills session. So listen to the class as well. The coming days, every day 5 to 6, and the repeat of this is what's going to be there in the morning tomorrow at 7 o'clock. So I want to tell you only one thing: make use of the sessions and prepare for the examinations effectively, and I hope you all are going through a smoother and comfortable level, and try to utilize the time as effective as possible, right? So see you again for the next class with another topic for another class. Okay, see you and bye bye.